All right, so calculus 1, you people, everyone that's going to be here is actually going to be here right now. Okay, and I know everyone's listening to me right now, so no one has earbuds in, just not paying attention, right? Lies. All right, finding higher order derivatives. So use implicit differentiation to find y prime, y double prime. What does y double prime mean? Second derivative. All right. Okay, and express y double prime in terms of x and y. Okay, so now I'm going to have it in x and y. So don't try to solve for the y to make it y equals. Okay, you have to just do implicit here. All right, so let's take a look. So first derivative. So my first derivative would be what? 2y dy dx minus 2x equals 0. Okay. All right, so that would be my first derivative, but now I have to do what? I do what?
Just 2x to the other side.
Okay, yes, get dy dx by itself, right? That's kind of what I was looking for. All right, so 2x the other side, so it's going to be 2y dy dx is equal to positive 2x, right? Divide by 2y. So I'm going to get dy dx is equal to 2x over 2y, which just gives me, what does that give me?
X and y.
X over y, very good. All right, so I got that one. So I'm starting with the first derivative there, dy dx. And so the next thing I'm going to do, I have dy dx is equal to x over y. Now, to take the second derivative, I'm going to do this thing over here. See this mess? What type of rule am I going to use for that dy, or x over y? Quotient. I'm going to do quotient, right? So it's a fraction, so I'm going to do a quotient. So that means that I'm going to label it f and g. So this is f, this is my g. So f prime would be 1, g prime would be dy dx. Very good. Yes? Okay. So I have that much information, so I'm going back here. All right, so let's go ahead and take the derivative. So when I take the derivative, the dy dx, this right here on the left-hand side, this is when I take the derivative of the derivative, it's going to turn into the second derivative. So this is going to turn into so second derivative of d, like that. Okay? So it's the second derivative of y. So second derivative of y in terms of x. Now, that's going to be equal to. Now, let's go ahead and plug it in. So it's going to be, remember, it's f prime g. Yeah, minus g prime f. So f prime g, so it's 1 times y, so it's going to be just y, right? Minus dy dx, so g prime f. So it's x times dy dx over y squared. Very good. Now, I have a slight issue with this. I have the second derivative here, right? But now right here with the dy dx, isn't that the first derivative? Say yes. That is the first derivative, isn't it? So whenever I'm doing implicit like this, I'm going to take a derivative and I'm going to have to plug back in the first derivative in here. Since this is the second derivative, like it says here, this second derivative, and this is the first derivative. Do I know what the first derivative is? Yeah, over here, x over y, right? So that has to replace my dy dx. So I could actually have just one function of just my second derivative. So now it's going to turn into y over dx squared is equal to y minus x times x over y squared. So now I have replaced my dy dx with the first derivative by plugging that in. And now from here, I could actually go through and clean it up a little bit. Right? I'm going to try and clean this up a little bit. So I'm going to have, let's see, that's going to turn into, okay, so now what would be the common denominator on the top? It's going to be y, right? Yeah. So y squared minus x squared over y. All that's going to be divided by y squared, right? Do you guys see what I did there? Anyone actually, did I lose you on this? Yes? Okay. So let's go back and take a look. What would be the common denominator? So it'd be over y, wouldn't it?
Yeah.
Let me change that to black. So y is the common denominator. So right now this is over 1, isn't it?
Yeah.
So I had to multiply this one here by y over y, right?
Yeah.
So when I do that, to get common denominator, that's going to give me y squared over y minus, this is already over y, isn't it?
Yeah.
X times x times x is x squared over y, right?
Yeah.
And then I just combine it with y squared minus x squared over y. Okay, does that make sense? So I was just common denominating that, that's all I was doing. Alright, so now fraction over fraction, I do not like them. So multiply by the reciprocal, right? So y squared minus x squared over y times 1 over y squared. And this is still my second derivative. So on the bottom, I'm going to end up with just y cubed, right? So it's going to give me y squared minus x squared over y cubed. Not too bad, right? The algebra is probably where it gets most people. The calculus concept is actually the easy part. The algebra is what kills most people here. All right, so we get that. All right, differentiating with rational exponents. So a rational is a exponent that is a fraction, right? So yes. Okay, yeah. So an exponent that is a fraction. So it's okay. So I'm going to rewrite these as a fraction first. So if I write this as a fraction, what would this be? X to the what? 1/2. 1/2. Very good. Now take the derivative of that. So where does that 1/2 go? In front, right? It would be in front. So it would be 1/2 x. Now what do I always do with my exponent every time? -1, right? But on this one, what is my 1 going to be? My 1's going to be 2 over 2, isn't it? Yes? So I'm going to subtract 2 over 2, which is going to give me -1/2. So another way of writing this would be 1 over 2x to the 1/2. So you can have it like this, you can have it like this, or if we end up rationalizing, which I don't care about now, at this current moment, rationalizing is no longer important. So in trigonometry, yes, it is important for that. In algebra 3, 4, maybe important, kind of, sometimes. Calculus, you can leave it there. It makes life a whole lot easier. All right, so let's take a look at the next one. So B. So that's going to be 3 times u to the 1/2, right? Yes? Take the derivative of that. 1 over 6?
1 over 6. 3 over 2. 3 over 2.
What's 1/2 times 3? 3 halves. Very good. So it's 3 over 2 u to the, very good, -1/2. So again, with my, now this one's going to be 3 over 2 u 1/2. All right, next one. X to the 5 halves. Okay, so I'm going to rewrite it because I like. There we go. All right. So 5 halves goes out front, right? So it's going to be 5 halves x to the. Remember, you're subtracting 1. So I said you're subtracting 2 over 2, right? So if I'm subtracting 2 over 2, I get what left over? 3 over 2. Very good. 3 over 2. Easy? Okay, so how about this bad boy here? So s to the negative 3 over 2. Goes out front, right? So I get a negative 3 over 2 s to the negative.
5 over 2?
Yep, 5 over 2. Yeah, and so negative 3, 2, s, 5 over 2 like that. Easy enough, right? Hopefully. Power rule functions. Okay, so now this is going to be chain rule to go along with it. We did chain rule, right? Chain rule. So the derivative of the inside times the derivative of the outside, right? So on this one right here, if I'm going to treat that whole thing like one item, it would be basically, let's call all of this right here u. So if that's u to the 5/3, that would be taking the derivative of the outside there. So taking the derivative of that piece right there, and it's going to be times the derivative of the inside, and we're going to do that here in a second. So u to the 5/3, what would be that derivative? 5/3 u to the.
2/3.
So yes, I'm subtracting 3 over 3, right? So this is 2/3 times, what is the derivative of the inside now?
3s squared.
So it's going to be 3s squared minus 2. Okay, so that's it. I did a little u sub right there just to be able to get this out so I could actually understand this is my u, so that's the derivative of the outside times the derivative of the inside. But now let's replace u. So if I replace u, put u back, that's going to be 5/3. My u is s to the third minus 2s plus 1. All that is to the 2/3 times 3s squared minus 2. Are we okay here? Okay, so let's take a look at this piece right here. This next piece, all that on the inside, I would consider that piece u. All that on the inside, I would consider that u. So all this is going to be u. So it's going to be u to the what? What would be my power for that one?
3 over 2.
Not 3 over 2.
2 over 3. 1 over 1.
1 over 3. 1 over 3. Because the top number is the power and the bottom number is a root. In the rational expression with the powers like this, right here, okay. So the top is a power, the bottom is a root. So on this one right here, I don't have any power. So if there is no power, there is 1, and the root is 3. So it'd be 1 over 3. Right? Yes? All right. So you tell me what this one is. Yeah. Yep. Okay. So there's that piece, right? That's the outside. Now, let's do the inside. So it's times the derivative of the inside. 4x cubed minus 3. Yep. Now that I did that, what do I have to do from there? Yeah, put u back in, right? Put whatever u was representative. So that's going to be my 1/3 x to the 4th minus 3x plus 5 to the negative 2/3 times 4x cubed minus 3. It's not too bad, right? Now, the next piece is going to be kind of a pain because it's actually 2 chains. So let's go ahead and I'm going to call all of this as u. Okay, all that's going to be u. Yeah, like I said, this is going to be 2 chains. So it's u to the negative 3 over 4, right? So if I take the derivative of that,
Negative 3 over 4, u, negative 7, so negative 7 over 4.
very good. So that's the outside portion. Okay, that's the outside portion. So like I said, this is 2 chains. So the next piece is this right here. Okay, that's the furthest in. Okay, the furthest in. So we have the outside, we have the inside, and we have the very inside. So now, the 3 theta, what would be the derivative of 3 theta?
3?
Just 3, right? So I'm going to have times 3. Here, let me color coordinate this so we know which piece goes where. There. And my last one is, what did I not account for yet? The tangent, right? Now, do you guys recall, what was the derivative of tangent?
Secant squared?
Secant squared, very good. So it's going to be times secant squared. Now, what am I plugging in for secant squared? So what is the angle I'm using? 3 theta. I'm not changing that at all. I don't change that one. So it's 3 theta. I know this looks kind of like a mess, but it is. Whenever we get 2 chains in there together, so we have 3 different parts that we're taking the derivative of. So we took a derivative of the outside, that's in red, took the derivative of the very inside, that's in black, and took the derivative of the tangent, which is in blue. So now I'm going to clean that up and put it all back together like it's supposed to be. So all of this together, so we said u is the tangent 3 theta, right? So that's going to be negative. I'm going to multiply these together. So 3 times 3, right? Negative 9 over 4. My u was tangent of 3 theta. And that is raised to the, what power? Negative 7 over 4, right? Times secant squared of 3 theta. Hopefully okay? Questions? Concerns?
Right, sir.
Huh? We good? Alright, so, okay, don't forget, like and subscribe, right?